Good afternoon to all of you, and welcome to the webinar on innovative technologies for treatment quality monitoring. As we are all aware, there are multiple stages in the waste value chain from generation to reuse. And the goals of the ecosystem around waste management have evolved over time to drive circularity via nutrient extraction and drive maximum reuse. To achieve this, one of the essential stages of the waste value chain is the treatment of waste. Ineffective treatment and its subsequent discharge have a direct adverse impact on the environment and water quality. Effluents from the treatment process are often discharged into surface water sources. Their poor quality is responsible for the degradation of the receiving water body and the health of its users. Quality and reuse also have a direct relationship. Treated waste output can be reused, be it recycled water or as compost. Acceptance of this by consumers will largely depend on its quality and the value that it provides. In the next 1 hour, we will discuss what are the current challenges with regards to ensuring treatment quality and its monitoring, and best practices in achieving this. In the later half of the session, we will also explore the latest module for treatment quality in digit sanitation. With that context, let me introduce you to the speakers on the panel. First, we have Surya Bharati Maji, who's a project engineer, Orissa Water Supply and Sanitation Board, and also an additional director at the Orissa Urban Academy, Government of Orissa. She's responsible for the construction and overall management of FSSM in urban Orissa, and also looks after grey water management for Orissa. Welcome, ma'am.
Thank you. Thank you for the lovely introduction.
We also have Praveen Nagaraja with us, who's the project director from WASH Institute. Praveen currently leads the capacity building at WASH, which engages in skilling and training a diverse set of stakeholders from among governments, private sectors, and academia. He has designed over 50 plus FSTPs in India and is keen on making treatment of fecal sludge as simple and robust as possible. He believes that technology should empower people to operate and monitor complex treatment systems with very little upskilling. Welcome, Praveen, to the panel.
Thank you, Dara.
Third, we have with us Krishna Swaroop Konidena. Krishna works as a senior program manager at CDD India. He has experience of 14 plus years across various roles and sectors, ranging from WASH, urban development, e-governance, and software development. He currently anchors the FSM vertical at CDD, focusing on monitoring and evaluation, treatment process optimization, hybridization, and capacity building. He's a strong advocate for the idea of holistic planning, decentralization, and systems approach, deploying nature-based solutions for solving WASH challenges, especially across smaller towns and communities. Welcome to the panel, Krishna.
Thanks, Dara.
Okay. And lastly, I'm Tahira Bharmal. I'm a product manager at eGovernment's Foundation. eGovernment's Foundation builds digital public infra and works with governments and markets to drive population scale digital transformation. In the sanitation space, we have built Digit Sanitation, a platform for managing the end-to-end waste value chain, which is currently deployed statewide in Orissa for fecal sludge management. Digit Sanitation is built using platform principles, ensuring that it is easy to customize for any waste stream or operating model, and can quickly evolve with changing dynamics and priorities of the waste management ecosystem. With that, let's get started. To start with, Maji ma'am, Orissa today is a model state for FSSM in India, with around 113 commissioned and 111 operational plants, and an innovative model for managing fecal sludge for rural areas, which is popularly now referred to as urban-rural convergence. How do you ensure that the system is up and running with minimum to no supervision? And what are some of the best practices that Orissa follows? Maji ma'am, I think you're on mute.
Okay, sorry. So, good afternoon, everyone. I'm Suryavati Maji, basically project engineer in OWSSB, and have an additional charge as additional director in Odisha Urban Academy. So first of all, it is my great privilege to be part of this esteemed panel. Thank you, Taira, for this. And all of you know that Odisha is pioneering in urban transformation. And one of the verticals is liquid waste management. And in that also, we have again decentralized it into grey water and fecal sludge management. So coming to this FSSM part, we have 115 ULBs and we have constructed 115 FSTPs and further 5 are under construction. So coming to the monitoring part. So construction part is done by the contractors. The first point is the O&M part has been handed over to the self-help groups. Here we call it Swachh Sathis, self-help groups, Mission Shakti groups. So basically the operation and maintenance is taken care by the people who reside in the area. So they ensure that the plant is run properly and the maintenance part, the USP of our plant is, it is nature-based, low-cost technology. So basically the liquid part, the treatment of the liquid part, it does not need any pumping. The entire liquid part goes by gravity for the entire treatment process. So when the SHGs are onboarded, we ensure that we provide a 2 months on-site training, making them aware of the various components and the various technology, because see, the SHGs, they are not very conversant. So the treatment part, we make them conversant in ODR, how you are going to take care of the plant and what are the minimum daily maintenance that is required. Because for the liquid part, there is absolutely no operation required. But for the sludge part, there is 2 or 3 pumping mechanism that is required for that. So for that, we have a critical diagram that is taught to them. You have to take care of this. Because if the sludge goes to the liquid part, that is to ABR and wetlands and the polishing pond, then there will be the treatment process will be hampered. So we ensure that the SHG that are taking care of the plant, they have to ensure that the liquid part only goes to the components and they have to take care that the solid part is pumped frequently to the drying bed. And the drying bed, the drying is taken care by the sun. Further, we have ensured a mechanism where we have variety of registers to maintain the how much load is coming. Currently, eGov has developed the app and it has been for the how much cesspool vehicles are plying in the particular ULB, how much load is coming, how much private vehicles are there, how much government-owned vehicles are there. So every day, by the end of the day, we have a database to see that yes, the plant is utilized to its maximum capacity or at least minimum 50% capacity. There is a marker that if it is less utilized or utilized less than 50%, then there is a trigger mechanism that ULB has to take care of that. They have to ensure that the minimum utilization per day is 50%. And then the training on the time of the onboarding, we are providing training. And also we are ensuring that refresher training courses are provided to the SHGs. Then we are also ensuring that cross-learning is provided because there are some ULBs that are performing very good. The outstanding performance is there for the ULBs. So they are also entrusted with the training of other SHGs to encourage them to perform better. And coming to the treatment process, that is, we have a technical resource person that has been appointed for the each FSTP. And the training is provided with collaboration with the WASH Institute. They are providing the training in batches. So the training is done in situ at Bhubaneswar. Maybe 4 or 5 days training is provided. And further, we are also taking care that they submit the report on a weekly basis. And they should know that we are testing the parameter, 9 parameter on a weekly basis from 5 sample points. So we are also ensuring that the treatment that is being done, the parameters are within the limit that is prescribed by the Pollution Control Board.
Awesome. That's good to know. One of the things that we've also seen working in Odisha is the responsibility that the TRPs take up. So we've been lucky enough to visit a lot of plants in Orissa, and one of the things that we see is that all of them are super beautifully maintained, and the TRPs are usually very up to date with all the activities that are going on, and work very closely with the ULB to ensure that the right practices are followed. A follow-up question to Krishna. So CDT is involved in a lot of R&D around methodologies and processes for wastewater. And a lot of these are implemented across plants in the country. What kind of data do you usually collect and need for going into R&D, and what are some of the challenges that you face in collecting this data?
Thanks, Saira. So we are looking at broadly two types of data, right? One is on quality and one is on quantity. Now, the quality requirements are in terms of, the effluent parameters, and then we have solids, right? So we have two outputs coming out from, say, a fecal sludge treatment plant or a, sewage treatment plant. So it will have effluent and it will have solids. Now, in terms of effluent, at the very basic, we need to look at pH, COD, BOD, total solids, E. coli, fecal coliforms. And for solids, the bare minimum, we need to look at moisture, pathogens, typically measured through Helminthics, what we do, and E. coli and fecal coliforms there as well. Now, this is at the very minimum, but based on reuse or disposal requirements, we look at more parameters, which could include nutrients, heavy metals, and also the calorific value of solids if you are trying to reuse them for, say, burning and those sort of purposes. And we also need information on the quantity, which is for a fecal stress treatment plant, like Maji was saying, we need to know the loading of the plant, how often the loads are coming, are they 50% loaded, 70% loaded, or 100% loaded, for which we rely on logbooks. At least most of the treatment plants are not computerized, so we rely on logbooks, how many truckloads have been disposed. And for STPs, we can also conduct flow measurements at the inlet side to understand, we have devices using which we can conduct how many meter cube of water is sort of flowing in a certain period of time. And over an entire day, we can try and understand what is the flow moving into the STP. If we are not allowed to do that, again, we have to rely on secondary data like logbooks or based on anecdotal evidence shared by the people. Now, going to the challenges, for example, if we take fecal sludge treatment plants, there are quite a few places where logbooks are not maintained properly. Not every reading is taken in the logbook, so that is one issue. And probably this goes back to them not being trained properly or them being not being supervised adequately by the urban local body. So there are instances of that. And there are issues like a truck can be, say, 4,000 liters in capacity, but the amount of fecal sludge that the truck is disposing may be less than 4,000 liters. It could be half a tank, but for all practical purposes, it can be noted as 4,000 liters were desludged on this particular drying bed or on a particular day. And the same is the case with STPs, where if we are not allowed to conduct flow measurements, then we have to rely on the anecdotal evidence of or the recorded evidence of how much wastewater is coming in on a daily basis, which may not always be correct. And if you are trying to draw conclusions based on these quantities, then it's a problem. Now, on the quality side, what we have seen is apart from pH, it is not viable and in case of a lot of parameters, feasible to measure these values on site. So, which in essence is all these samples have to go to a laboratory. Now, once it has to go to laboratory, it will exchange hands with somebody from the treatment plant to somebody at the laboratory. For example, if CDD is doing that activity, we have a laboratory of our own. We might deploy our own staff who are well trained in these processes to basically collect the sample, label the sample, store the sample, and transport it in a proper way. But if we have multiple actors, say somebody involved in FSTP operations and somebody who's involved in the lab, and both of them have to, handshake, then there could be a number of things which could go wrong in terms of protocols. Like everyone has to follow the same protocols in terms of how to collect the sample. The beakers have to be clean, the bottles have to be clean. They should not be contaminated, not even specks of dust or soil. when to collect the sample, right? If I'm getting a load today, right? If I have to collect a treatment sample from, say, a drying bed, what is the right time to collect the sample to assess the performance of the drying bed, and where to collect the sample? So that also has to be known, and this could vary from one treatment process to another. And labeling the sample, so we know which sample is what. When we do the analysis, labeling is very important, and we also need to physically look at the sample and say, how was the sample looking when it was taken, and storing the sample in ice boxes and hand it over to a lab within 24 hours period. And either it goes back to the refrigeration in the lab or it goes to the sampling table. So this needs to happen within a certain window. And then adding to this, where to take a grab sample versus where to take composite samples. Now, this is the entire story behind a sample, right? And this needs to be clear. So, and what we have learned is, of course, over a period of time, we didn't do it right the first time, right? So when we see results and then they don't make sense sometimes, that, the values are off, then we go back and ask about, how have these things been done at every step. Then we revisit the entire process and to see if there was something wrong. And more often than not, quite it happens that the values are off and they don't match with the regular observations because the procedures have been flouted at some process or the other. So over a period of time, as we do this more often, people who are not used to it, especially the operators and labs at faraway locations, will get used to this process of sampling. So those are some challenges that we have seen. Tyra, you're on mute, types.
Sorry. Yeah. So you did mention that there's a lot of changing of hands of samples that happen, and especially in rural areas, I believe that a lot of testing will be the responsibility of a plant operator, right? How do you ensure the integrity of the data that comes in?
Right. One way is to train, right, to work with the operators in the initial cycles and show them how it is done, and then also give them the information that is required. I'm sure Praveen can also throw more light on this, but it's important to work with them for a decent amount of time so that we are confident they know the process. And then we have got predictability in terms of the samples coming in and the results sort of making sense in the same way as they've done in other places. So, and that's why the integrity of the protocols followed across the cycle, from collecting the sample, where it's taken, when it's taken, how it's taken, then how has it been transported, and having some sort of markers, identification at each of these steps, right? And them not just remembering this, but actually documenting this or logging this somewhere, so that it's not on a need basis, but it is sort of embedded in the process.
Tahira, you're on mute.
Sorry. So Praveen, a question to you. While Krishna talked about treatment plants that are set up at multiple locations, one of the things that we've known Washa is working on is moving treatment closer to source, right? So not really relying on like the traditional method of waste being transported from one point to another, but treatment going right to source with mobile treatment units. How was that idea born, and how do you ensure treatment quality there?
So I mean, we had been to a lot of forums, the FSM conferences initially. I hope I'm audible and clear. Yeah. So when we saw that there is a value chain and there's clear emphasis that fecal sludge that's collected has to be transported somewhere and treated. So that's where the idea came that if the fecal sludge contains 95% water, why do you have to transport so much of water? You're unnecessarily transporting it. And then at the treatment plant, the first thing that you do is separate the water and the liquid, the solid and the liquid, and then treat it appropriately. So that's where the genesis of idea is. And then we brainstormed on what can be done to treat it on site. And there were technologies that were available in water treatment, in sewage treatment. So we kind of put together treatment modules that existed and saw how it worked, the efficiency of it. So the research and development was in identifying what kind of systems we could combine and what makes an economic sense and also easy to operate. So that's where the idea came, and right now we have patented it, and it's also approved by the Government of India, various committees. It's there on the GEM portal for urban local bodies to buy. Now the way Wash Institute being a not-for-profit and an NGO, so we don't sell and we don't involve in any commercial activity. So what we have done is we have licensed it to manufacturers, truck manufacturers in India. Now, in return, what they do is they plan to sell this to entrepreneurs. So they have identified, youth or self-help groups who can procure this vehicle. So this vehicle comes at, almost similar cost of buying a desludging vehicle. But the desludging vehicle only transports. So this can transport, this can treat, and then, can do two parts of the value chain. So the idea is, if we can involve local communities, youth, SHG members, for them to procure such a vehicle through loans from NSKFDC, banks, and other financial institutions. And they offer this as a service to urban local body. Because setting up a treatment plant, you need identifying land. And in a country like India, identifying a land itself is a time-consuming process. And, it might end up in litigations, and it takes a lot of time. So this solves all that purpose, right? Because it's mobile and you just need a place to park. So the question comes, how do we ensure that the treatment quality is maintained, right? So this has been one of the key parameters that we enter into. I mean, whenever we give a vehicle or sell a vehicle, we ask the person who's buying it. So we have installed an online sensor, an IoT device, which measures what is the kind of quality of wastewater that is being discharged. And this IoT sensor records everything online, and anybody with access to that dashboard can see on real time and through historically the performance of a treatment unit. So why it is relevant for Wash Institute? What do we have in it for us? Because we would like to see so many systems employed, and we would like to assess how good they are and probably make version 2 a better product of it. And also the most important thing is to make sure that these systems are actually solving the purpose for which they were built, right? Yeah. So that way, I think through this combination of technology and simplifying, it's very simple. You just install it. We work with Xylem, who's the provider of the solution, and they kind of made it cheaper, and they made it for the need that we had. And we have set it up, the dashboard, the backend, everything is ready. And as and when the trucks roll out and people start buying it, the ULBs can also get access to this data, real-time data for the kind of trucks that are there in their jurisdiction. So it makes compliance, it puts the onus of compliance on the entrepreneur or the service provider.
Yeah, that's quite fascinating, and especially now there's conversation around how do we adapt sanitation systems to changing climate, right? And with mobile treatment units, it becomes so much more cost effective to be able to service a large number of households and properties very regularly. That's great to know. I know that you'll have devices installed in mobile treatment units. What kind of experience have you had with sensors for monitoring treatment quality parameters? And I know Krishna's also been doing some work at CDD in using sensors for checking a few parameters. So would you like to shed light on whether these work, don't work, what conditions do they work under?
So, I mean, I think the sensor market is quite mature worldwide and even in India. If you want a good sensor, it's going to cost. And if you want something cheap, it will not give you the desired result, or consistency of result is going to be bad, or the functionality is going to remain very localized. It's not going to sync up. There are many such issues. So I think it's about working with the service provider and someone who is able to provide good quality products, good quality sensors, calibration units, and all, and then seeing how the cost can be reduced by only focusing on the parameters that you want to test. Because if you add a bulk of parameters as engineers and as monitoring specialists, we would want to know everything. So that just adds to the cost, and we want it to flow through SMS, be available on an application, etc., etc. So that just adds to the layers of cost. So if you know what is the bare minimum that you need to have, the data that should flow in, I think you can work with manufacturers and see how you can reduce the cost and make a robust system.
Awesome. Krishna, would you like to add something to that?
Sure. Yeah. And our efforts on real-time sensors were more on the drying of fecal sludge or even STP-based sludges, and understanding the impact of polycarbonate sheets, which create a greenhouse effect, and improve the effectiveness of sludge drying. This was done in 4 different sites: 2 in Odisha, 1 in Tamil Nadu, 1 in Bangalore. And for this, we work with temperature and humidity sensors, which are more established. Like, these are out in the market, and also probably in the affordable range. When I say affordable, we could get temperature and humidity sensor that could work in 60 degrees temperature and maybe 67% humidity at about 15,000, 18,000 in that range. Yeah, and then however, we also needed to measure the temperature and moisture in the drying beds, the solids in drying beds. And that proved difficult actually. Temperature was more or less possible. We were able to get it, but to get to understand the moisture level and even with regular sensors, like you have pin-based sensors that we can put in and just it gives us a reading, right? So those were also difficult to find or calibrate. So we probably tried 4 different models. We imported a couple from China, we have bought a couple from here, and then we tried to get the devices that are used to measure moisture content in soil and then see what can be possible. So within the affordable range that we defined, we could get a device which measured between 40 to 80% with some level of degree of accuracy, saying 80 to 90% it's okay, right? But above 80% and below 40%, we still had to rely on labs if we had to get the exact number. So that way it's working. And also I completely agree with Praveen that this is on the real-time measurement market. It's a evolving situation, and we need to work with the there are various people who are doing work in this sector, but we need to work with them to come up with something that is affordable and and then work with them to take this forward. So our approach has been to see while this can happen over a period of time, right, is there something that the operators can still be empowered with, even with a small tool that they can hold in their hand, which is like for pH meter it is still available, right? And at home we have our, if you want to check the TDS and the water that we are getting, the hardness, then we put that, we dip it in, and then we get that. So at least a reasonable level of equipment that could serve that purpose. That is probably the medium term goal that we have. But in the long term, we need to get to a regime where we can get data really in real time.
Awesome. So that's interesting, because what I'm hearing is that you can use some of these devices not only, obviously they're costly, but you can use this not only to test output or quality output parameters. Another use case of these is just to measure how processes are working, so that you can take proactive action in remedying quality challenges that you might potentially have. One of the things that I've also seen, and I read this somewhere, is that once you start accumulate, so while the efficient or the readings of the sensors might not really be accurate at that moment of time or for that particular test, when you start having these huge batches of data across multiple plants, what you can do is put them together to be able to predict quality issues in different processes, different stages. To Praveen, Krishna, since both of you all are quite involved on ground in terms of research and of processes in general, what do you think are use cases of real-time, large-scale data in improving monitoring? And also further extending this, I think Maji ma'am's been super involved in using data to keep monitor to keep plants up and running. So what kind of data does the state require? What kind of data does research organizations require? Just an open question to the entire panel.
If I may go ahead.
Sure.
So, a part of what I do right now is also to develop training modules and build capacities of different kind of stakeholders on wastewater and fecal sludge management. Now, when we touch upon technical subjects, we all realize that, even the manuals that are there of how do you design treatment systems, whether FSTP or STP, rely completely on empirical data. It's empirical science. There's nothing theoretical about it. And a lot of these, so for empirical science, you need answers or coefficients which are based on certain observations, experiments that have been carried out. Now, these experiments date back to 1970s and 80s, and they haven't been updated yet. And even now, the research that you see that happens in academia is not on the foundation or trying to change the empirical evidence and make it contextual to India. It's more of how do you apply. So data from treatment plants will help us improve this empirical science of designing treatment plants, because designing treatment plant is all about seeing how existing treatment plants work either in a lab scale or in real ground, and how you can theorize them into some kind of formulae. So with this data will help the academia, the R&D practitioners, everybody enormously, and which has not been a focus at all as a group of practitioners. So I think that that's something that I wanted to bring about. Yeah. Over
That's
to
interesting. Krishna, Maju ma'am, have you all seen interesting use cases of this data?
So I completely agree with Praveen, because currently we are focusing on two major aspects as far as monitoring at state level goes. So first is plant utilization. See, we have constructed an FSTP in each of the urban local body. So unless the plant is utilized, the purpose is lost. So here we take a weekly call and a monthly utilization report is generated. How much utilization is there? Because see, we have constructed the plant, we have designed the plant based on the population of the urban local body. So if the plant is underutilized, that means the septage from the septic tank is going somewhere. That means it is getting discharged illegally. So we have a mechanism developed that if the plant utilization is less than 50%, then the ULB, the executive officer of the ULB has to take a call. He has to inquire, because we have a comprehensive mechanism developed that how many cesspool vehicles are running in the urban local body. And if it is privately owned or government owned, all of them have to be registered in the ULB. And we have a IC activity going on. Each household is visited by the Swachh Sathi in the particular ward, and they make the people aware of this project, that there is a FSTP set up in the urban local body. You have to call the registered vehicle only. You cannot call random numbers. You have to call this vehicle, and you have to also, the app is developed by the eGov Foundation. So the cesspool vehicle data starting from the request to the disposal is monitored. So unless the vehicle disposes in the plant, the call is open. That means either the vehicle is on the way or he has discharged it illegally. So the ULB takes a review on a weekly basis, and the information is collected at the state level on a monthly basis. So if the plant is running in between 50% to 90%, then it's not a matter of concern. The second parameter is the treatment. So each FSTP has a well-equipped lab to test 9 basic parameters. And the TRP are trained. They are provided refresher training courses also. So ensure that the BOD and COD, at least these 2 parameters, are within the limit prescribed by the Pollution Control Board. And they are also, we have a database that is updated on a weekly basis. So they have to collect the samples from 5 sample points and test for 9 parameters on a weekly basis and upload the test report in the prescribed format given by the state. So if the plant is, and another, we have another in the review meeting, we also inquire about the other important things such as the pump operation, if the lab is up and running, if there is a chemical issue, shortage of chemicals, or the equipments are broken or something, and if the solar setup is running, PP kit is provided or not, proper maintenance is being done or not. So in a weekly call, we take care of these things. So basically, we take care of the plant utilization as well as the testing that is done by the TR.
Awesome. That's good to know that that we're collecting so much data across operations to ensure that no waste is going untreated. So why one question I have, and this could be answered by anybody on the panel, is that while we're able to collect some of this data at say probably a plant level or a district level, scale is India has invested and is continuing to invest a lot in terms of setting up treatment plants and just waste management technologies at scale, and a lot of capex has gone into that over the past few years. So while it's easy to coordinate and get some of this information for a plant level, what do you all think are ways to do this at scale across all plants?
Yeah, so I'll probably take that first up. So scale is a scary business, right? Because, and I'm coming from the point of view of how mature the measurement market is, or the whole ecosystem is. So I think we are just starting out there. And as you rightly said a little while back, you asked about the integrity. So if every point from where you're getting your data is, integrity is assured of that, right? So every treatment plant, fecal sludge treatment or sewage treatment plant or grey water treatment, whatever it be. So every point is, the integrity is assured of that, then it's not very difficult to this data to get, into a dashboard at the district level or a state level, right? The difficulty today is ensuring the integrity of that particular plant. And I say that because before we get to scale, and Praveen was also talking about why real-time data is important, or probably one more issue is the thumb rules that people have, right? Everyone, if you go around 10 practitioners, so everyone will have 10 different thumb rules for doing probably the same thing. Now, data, one is, it needs to get to that level where these are not too far away. The thumb rules are, people cannot get away with saying, thumb rules which are not really proven. That is one, right? And once that happens and the system is a little more mature, right? So what happens is then we can get to a stage where, for the data to make sense at a state level, because then we can make decisions on that basis. Today, we are very far away from that from a treatment perspective. I'm not talking about, say, the entire GIS marking and, making sure whether the trucks are within the operational range or they've went out. So those sort of things are easy to do and very specific to treatment. So that, I think the ecosystem has to mature a bit more. We need more integrity into the operations that are being run across different processes. And once that happens, the data can flow to any level that we want to, and then decisions can be made easily. Right?
Awesome. Yeah, Praveen.
So, recently, I don't know if how many of us have been following the NGT has pulled up all the pollution control boards from CPCB and even state pollution control boards asking what is your staff strength. Apparently, there are media reports which say only 50% of the allocated staff strength is the number of staff that are there in these pollution control boards. And the gambit of pollution control board is to monitor everything. Imagine right from nuclear power plants to industries to small scale industries, and the last thing being a fecal sludge treatment plant in some remote corner of a ULB. So and because they are short they are short-staffed, and then there are so many litigation that happens between agreed parties. So they are so involved in just, in this entire litigation process that they don't have time to actually go check the performance of a lot of these treatment plants. So we need to move to a culture where the onus of reporting on treatment rests with the operator, right? It is not for the pollution control board to tell us whether it is working or not. That onus should go to the operator, right?
Yeah.
And this has to be made transparent, right? Through technology. Now, in one of my field visits last year, I went to a very small town called Sahibganj in Jharkhand. So they have, under the Namami Gange program, they have a very good STP that have been set up. And what they have done is they have installed a setup, an IoT system at the end of the treatment plant. If that monitors all the parameters and it goes online. So anybody, you and me, even right now sitting in front of a laptop, can access and see what is happening as we speak in the treatment plant. And at any point in time, let's say the IoT device goes down because of electric failure in half an hour, there's a penalty and so on and so forth. So that it ensures that the device is not just there, but it is continuously live, calibrated, and all of it. So it just, then you don't need a pollution control board. Even the mission directorate of the Namami Gange can see the output that their systems have bought. So I think this is something, this is a radical change in how we look at who should be who should actually collect samples, treat, report, and how this entire monitoring should happen should be reformed. Yeah.
Awesome. That's good to hear. I do completely agree with you in terms of the role technology can play in both, like automating testing to ensuring that there is real-time feedback going to trained or untrained operators in terms of if something is wrong, and that data also having a very clear escalation matrix in case it's not solved at that very moment. I see there are quite a few questions coming in. I'd encourage everybody in the audience to put in questions on chat. We'll take that right after in about 10 minutes. But over the next 10 minutes, I'd just like to talk a little bit about the treatment quality product that we've introduced on Digit. A lot of you know that Digit is a platform for urban governance built by eGovernance Foundation, and one of the use cases we specifically cater to is sanitation, which, like Maju ma'am mentioned, is rolled out across Orissa for fecal sludge management. And while the platform currently catered from the point of generation to the point it reached a treatment plant, one of the things we thought was missing was the monitoring of treatment quality to ensure that all the effort that is put into the first half of the value chain does not go to waste. Through the platform, we believe that we could ensure there is regular testing, and this is one of the bases that we kept when we designed the platform, that testing should happen on a high frequency, regular basis. Results of testing should be available to all, and the system should, and like Praveen mentioned, the system should be able to give operators an indication if treatment quality is right or not, but also have an escalation matrix that informs all stakeholders when something goes wrong at a particular plant, and then data is accumulated over time to help researchers, to help the state in terms of overhauling treatment processes and ensuring improved treatment processes for improved treatment outcomes. I'll quickly give you a quick glimpse of the platform. Let me just share my screen. Can somebody give me a quick thumbs up if my screen is visible? Awesome. So the first thing that we thought about while designing the platform is that we want complete autonomy to be with the state or any implementation partner to be able to set up the system in terms of parameters that they want to test, the frequency of testing, and the platforms gives you a UI layer to be able to do this. So through what we call the workbench, you can easily manage master data at both the state and a particular cluster or a ULB level. So what it allows you to do is set up multiple things, right? First is the list of plants that are in the governing boundary. Additionally, what are some of the process? One second, sorry. Yeah. Additionally, what are some of the processes that are running in these plants? What are the multiple stages that you want to test at? What is the quality criteria that you want to establish? And then ULBs, urban local bodies, or clusters, as we set up for managing these treatment plants, can set up what we call as test standards. Test standards is basically accumulation of the plant, the process, the stage, the material you want to test for, and how often you want to test. So for example, if a plant in Daspala wants to regularly test their fecal sludge process, and within that process they want to test out the output of the screening stage every 7 days, they can simply configure that test through this UI. And what this does is it creates that test automatically for the plant operator to fill in, and also allows you to test compliance against the testing. So if this test had to be filled in every 7 days, but the plant operator has skipped the test over the past 10 days or over the past 15 days, you'll automatically know that the testing is not happening. I'll quickly show you what it looks like for the plant operator. Now, while I bring up my screen, just want to point out here that while you see this for a plant operator filling up this data, the system is built in such a way that it can not only cater to that use case, it can automatically connect with any devices that might be available, be it IoT sensors, be at treatment plants, be it any other machines or handheld devices that are being used for testing. There is integration possible so that data can completely flow in, and the base settings that are being done, the base settings that are being done for the tests are easily replicated across each of these devices as well to collect data at that frequency and for those parameters. Let me just log in as a plant operator. Sorry. So this is the mobile app that the plant operator would use. It can work on desktops, it can work on mobile. So any device that the plant operator is using at your particular plants, the system can be used there. And when the plant operator logs in, what they basically see on the screen is a list of pending tasks. And these tasks are basis the frequency that we just configured, right? So 7 days, 14 days, you can trigger pending tests basis that, and the plant operator will easily, when they log in the morning, be able to see what are the tests that are pending for that particular day, and be able to see what that test is for, right? So when they have to collect a sample, they'll easily know that if I have this process, I have to collect a sample at this stage for XYZ output type, and this is the parameter that I want to test. There's obviously different models of operations that are in treatment plants, right? So either you, like Orissa, you have treatment that's happening in-house, or there is samples being sent out to third-party labs for testing. So this system can be extended either for the plant operator to use or for third-party labs to use. And you can easily record which lab the sample has been sent to. And once the sample has been sent out, there's an easy way for recording what the parameter is. So say, for example, say the test result is 60, you can make it mandatory for people to update supporting documents, be it, like Praveen mentioned, a picture, like Krishna mentioned, a picture of the sample that is required for you to verify the results. Or if it's a machine that is being used, you can say, hey, a picture of the result on the machine is mandatory, and those files can be updated. And once that is done, what the operator gets to know is whether the treatment quality result is up to standard or not. And while we're seeing one parameter here, this can be configured across multiple parameters. So for example, in the inbox, which is a place for you to be, for the plant operator to be able to see all of his tests. Sorry, let me just open up a test, which has, you can say, hey, I want to test BOD TSS as well as one test, and basis different parameters, configure multiple tests which will be triggered to people. What the plant operator can also see on his home screen is, just give me a second, it's acting up a little bit, is the performance of the plant over time. So they'll be easily able to see what has been their test compliance, or how often they've been able to complete tests as per schedule, what percentage of quality tests have passed or not passed over a particular time period, and what are the number of alerts raised. And they can simply go and view past test results as well. Just give me a second. Yeah, so they can simply go and view past test results as well. This is the test that we submitted recently today, and a record of all of these tests is available for them to view and share with multiple people. An additional user that has control on the system, and this user can be given out to multiple people, be it somebody who's sitting in a governing body, the pollution control board, state administrators, so on and so forth, is to be able to view the list of tests that were to be submitted, and also additionally be able to view record ad hoc tests. So one of the questions that we discussed in the session was how do you ensure integrity, and especially when testing is completely reliant on plant operators. And we thought, why don't we provide a provision for somebody to come in and take surprise a lab test and be able to record it in the system, so that you're able to actually compare what is being done by a third party or a monitoring agency to what is being recorded on a regular basis by plants. And and that can be done through ad hoc tests. So this is the screen of the governing body, and what they're able to see is the list of tests that are scheduled across plants in their inbox, and what stage they're at. What they also get in their home screen is a set of alerts, and these alerts are completely configurable. We've set them up for two things. One is if test results are not submitted on time, and secondly, if test results are not as per benchmark, these notifications trigger up. So you can complete, as soon as the test is submitted, you also have information as somebody who's governing the system to be able to say, hey, there's an intervention needed. And just like the treatment plant operator, you have access to all your past test results across plants that you're responsible for, and you can look at what parameters were tested, what are the benchmarks, and what is the performance against those benchmarks. And like I was mentioning, there's the ability to add ad hoc test results for a particular plant. So you can select a plant, the treatment process you're testing for, and we understand there are plants which might have multiple treatment processes that are ongoing. So you can select which one you want, which stage you're testing for, what material you're testing for, and the parameters that are configured against this in the system automatically populate. And as a user, I can just record these parameters, add additional documents if required, and be able to see these test results. Sorry. So this test result gets recorded and is accessible through past test results as well. And additionally, what administrators get is a comprehensive dashboard that will allow you to look at this data over time, interact with the data, and be able to deep dive and find anomalies that will help in decision making and quick interventions. So that's a quick view on the module. Happy to answer any questions. So let's just, I know we're a little short of time, and we'll take about 5 minutes extra to take a few questions from the larger group. I think there's one question to Margie ma'am. What's the plan for managing the huge amount of biosolids that come in from 115 FSTPs?
Yeah, so the biosolids is getting collected in a sludge storage set. We have built a sludge storage set in each of the FSTP, and currently we are filling up government land. It is used as a land filling because it cannot be used as a fertilizer. It is basically dried sludge. So we are currently using it as a land filling in government lands.
Okay. Okay. And is there like a plan to monetize this in the future?
Currently, we are under a process of having a co-composting. We are piloting the process, but maybe in the next 6 months or so, we'll freeze the SOP, and maybe we'll go ahead with the co-composting of the sludge with the municipal solid waste. We'll have a co-compost. That plan is under process. We are currently in the pilot stage of that process.
Okay. Okay, got it. I think there were a few questions that were already answered. There was one around revenue generation. Are there any other questions that are from the audience that we could take up before we wind down on the webinar? There's a question. What is the advantage of the system when compared with online continuous measurement? The system described involves more of human interventions, is my understanding. I'll take a crack at this. So like I mentioned during, so one, as a base, the reality is that most treatment plants are not equipped with sensors yet, right? While testing is happening, most of them are relying on people to collect samples and test out these samples and report results. So the first thing that we wanted to do as a base of the system is to ensure that treatment plants, that there is an ability to be able to record a lot of this data, and for the governing bodies to be able to see this data and ensure that one, tests are being done regularly, and secondly, to be able to quickly identify which plants are not as per treatment quality. With that said, the system can integrate with sensors at any point of time for its working. So as you all saw, there was somebody filling up a form to record results. That data can automatically come in from a sensor when integrated. We are a long way off from sensors being installed across plants in the country, but the system is ready for it as and when that happens. Okay, I think there's another question. Do we have any dashboard glimpse? Yes, we do. I didn't display the dashboard because it has live data, but we will share that across as a post mailer after the session. I think that's about it in terms of questions. Just wanted to see if anybody on the panel had closing remarks, and then we'd wind down. Happy to answer any questions over email. So if anybody in the audience has questions that come in as an afterthought, more than happy to discuss it.
Yeah, Taira, I mean, thanks for taking us through the application. I think this is very much the need of the hour. And, something like this is very, very useful, especially given that we might see another 10,000 treatment plants in the country, both urban and rural areas, in the next 4 to 5 years. So of course, there's going to be a lot of learning for us as well, of how we can make this more easy and customize it for some of the needs of state governments. But I'm so glad that we finally have a product which people can use. Yeah, thank you so much for taking us through this.
Thanks, Praveen. Awesome. I'd like to thank everybody who joined us on the panel today. I think your insights were super useful. I know there's a lot that is being done by governments, by ecosystems, in terms of tackling this entire problem of waste that we have. And a lot of you all are doing pioneering work in this. So thank you both for your contributions and for coming and speaking about them in this session.
Thank you, Taira, for including me in this panel, and thanks to all the attendees also.
Yes, absolutely.
Thanks, Taira and the eGov team, and also thank you for all the participants for giving us a patient ear. Thanks, Praveen. Thanks,